So, a very good evening to all of you. So, let me welcome you to this live session on the course Switching Circuits and Logic Design. Due to some technical glitch, we are a little delayed. So, we are sorry for that. So, we have received some of the questions from you. Let me start by discussing some of those questions. Subsequently, as the session gets live, you can post more questions, we can discuss all of them, right. Okay. The first question I would like to discuss about is, someone asked, why do computers use zeros and ones? What is the purpose of that? So, this is a very basic question, but you need to understand this very clearly, that why 0 and 1 in a computer. Well, let me try to explain this in this way. Well, all computers today are built using some kind of semiconductor technology. Almost all of these computers are based on a semiconductor technology called Mos transistors, metal oxide semiconductor field effect transistors. These Mos transistors are very small, minute electronic elements. So, inside an integrated circuit today you can have more than a billion such transistors fabricated, right. They are very tiny electronic devices. Now, the way these electronic devices work, they are 3 terminal devices. Depending on the voltage you apply on one of the terminals, the other 2 terminals, they act like a switch. They are either turned on or turned off. Just like you can turn on and turn off a light or a fan, very similar to that. So, you can imagine that these Mos transistors act as micro miniaturized electronic switch, and a switch can be in one of 2 states, as I said, on or off. Well, if you think about circuits from a different perspective, from the point of view of currents and voltages, there also you can say that on a line either a current is flowing or it is not flowing. At a point either there is a voltage or there is a no voltage. So, there are 2 states of the circuits we are talking about, a switch being on or off, a current being flowing or not flowing, a voltage being present or not present. These 2 states are conveniently mapped into a mathematical formalism logic, which is called switching algebra, where we talk about logic 0 and logic 1. These 2 states, like the switches being on and off, they can map to logic 1 and logic 0. This is why in computers or in any digital circuits and systems, we talk about binary systems, we talk about zeros and ones, because the way basic calculations or computations are carried out, they are carried using digital signals which are either 0 or 1 in 2 discrete levels. Okay. So, I think I have been able to answer this question to the satisfaction of the person who posed it. Okay. This second question I would like to take up is very interesting. The question says, how switching is different from software? Okay. Well, someone may ask that, well, this question is like how a car is different from an apple. So, you are asking a question like this, but well, I think it is not, it is a very relevant question. Let me try to address it in this way. Think about a software. What is a software? A software is a set of instructions or commands that are used to solve a specific problem. A software can be developed using some so called languages or programming languages. There are so many programming languages you must have heard, like C, C++, Java, Python, and there are many others. So, given a problem, for example, you want to find the factorial of a number, you write a program which is a set of instructions. Well, now my question is, you have written the program all right, but how do you compute the factorial? For that, you have to run the program on a computer, and computer is a hardware, it is a digital system, there are a lot of electronic circuits inside, and to build those electronic circuits someone must have built those circuits, because of which you are able to run the software on top of it, because if there are no computer, you would not have been run any software on it, right. So, the persons who are building those computers, the hardware, they have to deal with the switching circuits and switching algebra. They talk about gates, flip flops, registers, adders, circuits. This is how they get related, right. So, these two terms, switching and software, they may seem to be very irrelevant, but no, they are very much connected. Well, you have a hardware where all these switching circuits and switching algebra comes into the picture, and on top of the hardware you are running the software. Okay. This is like an ecosystem of computing. You have the hardware which someone has built for you, and on top of it you are developing software, right. Okay. Now, let me talk about one question where someone asked, well, this is a slightly higher level question, that what are the current research trends in the VLSI domain. VLSI stands for very large scale integration circuit design, and what are the domain of VLSI that are used in industry nowadays. Well, this is a very broad question to answer, but let me tell you a few things related to this question. This course on switching circuits and logic design, this is a foundation course which is supposed to equip a person with the basic technologies using which the person will be able to build small systems. Small systems, I am not talking about hugely large systems, I am not talking about a computer systems you are building, no. You are building an adder, you are building a multiplier, you are building a multiplexer, small systems. Now, when you go one step further, when you talk about VLSI or very large scale integration, there you talk about very large systems, where number of gates or number of transistors can be of the order of millions or billions, very huge. But whatever you have learned as part of this course, unless you know this, you will not be able to grasp the basic concepts in the design when you are doing a VLSI design. Okay? And because of the sheer size of the VLSI design, because they are so large, so huge, you cannot carry out the design by hand. For example, for very small switching functions, you are able to minimize them using Carnot map or switching expression and derive a gate level circuit for it. But suppose I tell you that I have a function where there are 1000 inputs, there are 50,000 product terms. How do you minimize? How do you arrive at a gate? Do you sit down on and try to do the calculation on a piece of paper? It is simply impossible. You will have to use the computers for that. You will have to use some software, those are called design tools, those are called electronic design automation tools, VLSI CAD tools, computer aided design, they are known by various names. You need to use those tools. There are some industries which specialize in developing such tools. Those software are available from companies like Cadence, Synopsys, Mentor Graphics, Xilinx and so on. So, if you have those software available to you, you can use those software to develop or design large systems. But naturally, when you talk about very large systems, you do not specify the functionality the way you do it just like a truth table or a switching expression. You talk about some kind of programming language. There are some very specific programming languages that are meant for hardware design. There are languages like Verilog, VHDL, System C. They are all specifically meant for designing hardware systems. But of course, these are all advanced topics, and the course that we are talking about now or today is a very basic first level course, or you can say the first step that you must take before you master the next steps of these design tools, VLSI design, this kind of hardware description languages and so on. Okay? All right. There are a couple of questions on internships. Well, I know many of you may be interested in internship opportunities in so called better places or better institutions. Possibly the place where you are studying, you may not be having all the facilities. I mean, you may not be getting the exposure of all the software and the tools that possibly, I mean, if they are available to you, you could have learned some of the concepts in a better way. Okay? Okay, without going into the details, let me tell you that under this NPTEL platform, there are opportunities for carrying out internships. Well, just even without this NPTEL platform, you can apply for internships in institutes like IITs and other places. They accept interns. They have a regular process of selection, and if they find you to be good enough, you can be selected as an intern. Besides that, with respect to this course, let us say, if you perform really well in this course, if you are one of the toppers, then NPTEL gives you an incentive. NPTEL allows you to carry out internship in one of the IITs. Let me give you an example. Two of the students, they were toppers in two of the courses which I had offered last time. They came to me this summer to carry out internship under my guidance. So, this kind of opportunity is there, and this can also be an added motivation for you to do well in these courses. Do the assignments very seriously, listen to the lectures regularly, and also read books beyond that. The video lectures that are made available to you, that is not the end of the story. That is just like introducing you to the subject. Okay? Fine. Sorry. There are some queries, of course, it is not very clearly mentioned. There are some queries about 2's complement, but let me take the cue from this and let me try to have a very brief discussion on this topic. Well, as I had said that in a digital system or a computer, we have very tiny switches. We work in the binary number system, zeros and ones. But when you build computing machines, we have to deal with numbers. We have to store numbers, we have to manipulate numbers, we may have to do some addition, multiplication, division and so on. So, we have to have some mechanism to store numbers in a computer. Well, in these switches you can store a 0 or a 1. A collection of these zeros and ones make a number, a binary number. Now, in the lectures I have talked about sign magnitude, 1's complement and 2's complement number representations. They are different alternative ways to represent signed numbers. Numbers may be positive or negative, and if we have this kind of representation, you can build some circuits to add such numbers, to subtract such numbers, to multiply such numbers and so on. In particular, 2's complement number system has some very nice advantages, because of which it is quite universally used in almost all computer systems nowadays. This 2's complement has an advantage that you do not need a subtractor circuit. Just using addition alone, you can carry out subtraction. So, when you store a number, you do not care it is a number is negative or positive, you say that it is a 2's complement number. If the number is negative, if you add it to a positive number, it means you are doing a subtraction. It will happen automatically, right. And of course, there are some additional advantages of these numbers which are there. Okay. Now, there are a couple of other questions also which I have received. Let me take them up. Well, one thing is, it says that it is important, is it important for chemical engineers? That, well, you see, whatever I am discussing as part of this course, it is a basic level course, first level course which is taught in the first or second year curriculum in computer science, electrical engineering or electronics engineering courses. This course is necessary to understand in a better way how a computer system works. So, even if you are a chemical engineer, well, everyone today is using a computer. So, the mobile phone that you are using today, that itself is a very powerful computing engine. There are 4 core or 8 core processing engines inside your mobile phones. So, if you are inquisitive, well, you may ask yourself that, well, how is this working? How does this calculator work? How does this mobile phone work? How does a computer work? To answer such questions, this course is certainly necessary. Well, do not think that every course is required only to pass an examination. It is required only towards fulfilling some objective for getting a degree. Well, you are trying to become a complete individual. Knowledge has no boundary. Well, if you say that, well, I am a chemical engineer, I should not know this, that is not my domain. Well, you should not think like that. If you feel that you are getting interest in that, it does not matter whether you are a chemical engineer or not. You can also learn VLSI design, you can also do circuit design. You look at other countries like US, there this kind of interdisciplinary works or activities are very common. Okay? So, this kind of demarcation of boundaries, at least I do not believe in that, and so you can take encouragement from this. Okay? Fine. Well, there was another query which says that can you explain in Hindi? Well, of course, if I get some specific questions, I can try to explain in Hindi. Well, I can speak in Hindi, may not be very fluently, but I can speak. But in the regular lectures, it is not possible to deliver the lectures in Hindi, because of obvious reasons you can understand. The slides which have been prepared, they are in English, and the discussions that you are doing, the calculations that you are doing, they are also in English. So, using Hindi to explain may not be very convenient, but if you have any specific questions, then you can come forward and ask them during these live sessions. We can try to answer them in Hindi if possible. Okay. Sorry, I have a bad throat. Okay. There is a question. This question says that during addition, why do we get overflows? Take a small example. Suppose we are talking about 4-bit numbers, numbers stored in 4 bits. Now, in 4 bits, if you say that numbers are unsigned, numbers can be 0000 up to 1111, which means 0 to 15. Okay. So, in 4 bits number can be 0 to 15. Suppose you are adding 2 such 4-bit numbers, the maximum number in 4-bit can be 15. So, if you add 15 and 15, the result will be 30, and 30 if you represent, you will be needing 5 bits. In 4 bits you cannot represent. This is what we mean by overflow, that in certain number of bits we can represent numbers only up to a limit, beyond that we cannot represent. So, if we are not careful, if we are adding 2 numbers which are very large, the result can become erroneous, okay? Because you know how binary addition is carried out. If you add 2 4-bit numbers, let us say, the 4 bits will be added and the 5th bit that is coming out, that will be discarded. So, whatever you will be getting, that will be a wrong result. That is what we refer to as overflow. Okay? So, in arithmetic you need to detect and handle overflow. Now, there is another question which has come. This says, can you tell us about real world problems that need solution and need to solve by engineers? Well, so whatever we do, they are driven by real world problems. Well, unless you are a mathematician who does something out of fun, the true mathematicians, they do not care about applications. They say that, well, I am doing this because I love mathematics, I do not know where the application of this is, but the question that you have asked, that well, when you look at a problem, let me take a very simple example. You have seen in Kerala, there was a natural disaster. There was a flood which caused immense hardship to a large number of people. Now, this is a real world problem you are seeing, you are facing. Now, using this input, you can think that well, in what way you can possibly develop a system where if such a thing recurs in the future, you can possibly handle them in a better way. Well, there are so many different kinds of technologies that today you can use even in the face of natural disasters. Like one example I am saying, for natural disasters like this flood, well, everything gets flooded, everything gets shut down. There is no electricity, there is no mobile connectivity, there is no networking. So all connectivity stops, and in today's world, if connectivity stops, then we all feel so helpless. So now you can say that well, I can think of a solution that when such a natural disaster occurs, let us have a system where we will be flying drones. Drones are now very inexpensive and affordable. Drones may be equipped with some kind of Wi-Fi or wireless hotspots. They will be connected with some kind of base station somewhere. So, these drones can be moving around in some regions where people may require some connectivity or to communicate with the outside world. Now, using this kind of a technology, you can possibly provide them with some kind of a ad hoc networking solution. These drones connected among each other, in turn connected to a base station. This is an example of a mobile ad hoc network. So, you can create such a mobile ad hoc network on a manet on the fly, and this can be immensely beneficial in such disaster situations where the ground level infrastructure may be totally inoperational. Now, coming back to your questions, so you have to be on the lookout for real world problems. No one will tell you that these are the problems you have to solve. You will have to reach out, you will have to look out, look for problems, try to find out what are the important problems that need solution. Adequate and good solutions are not available, and then you apply your head to come up with some feasible and effective solutions for them. Now, if we have this kind of a, you can say, mindset, and if you can come up with this kind of solutions, this can transform you into an entrepreneur. Now, you will be called an entrepreneur. You can identify problems, you can formulate solutions to the problems, and ultimately these solutions will be beneficial to the mankind, to the society, right. Okay. Okay. Now, there are some technical questions which has come up. There is a question which says that everything has been done manually by us using Carnot maps and tabular methods. How can they be done programmatically? Okay. Talking about Carnot maps, Carnot maps were developed with the sole objective for doing it manually by hand. it is a pictorial kind of a solution tool. So, you cannot expect that Karnaugh map will be used in computers to solve the minimization problem. But the tabular method, you think of the Quine-McCluskey method, you can write a program fairly easily to implement this tabular method of minimization. But you talked about that whether some libraries are there. Well, you do not have any libraries available in the public domain. There are no libraries as such, but you can write a program to implement this kind of a tabular on Quine-McCluskey method, and you can solve minimization problem. You can go up to 15-20 variables also, let us say. Okay. Now, talking about software tools, as you had asked, like libraries. Well, libraries may not be there, but I talked about the commercial tools from Cadence, Synopsys, Mentor Graphics, etc. As part of those tools, these minimization packages are available. They do not use Karnaugh map, they do not use this kind of Quine-McCluskey method, because these methods cannot be used for 100 variable or 1000 variable functions, which most of the practical problems need to solve. The real problems are of that size. So, they use some kind of approximate methods. Most of the design tools that are used in those commercial tools are approximate methods. They try to get a good solution in a reasonable amount of time. By no means it is the minimum solution. Like when you do using Karnaugh map or the tabular method, it is guaranteed that the solution is minimum, but in the approach that is followed in the tools, they use approximate methods. There is no guarantee that it is a minimum solution, right. Okay. There is another question regarding Hamming code. It says some of the communication textbook use MSB to LSB and digital circuits use LSB to MSB for position D3, D4 and so on. Which textbook are standard? You see, there is nothing like standard, it is a matter of convention. Well, even in a particular subject, if you open two textbooks, the authors have chosen to use two different conventions, but the convention that most of us tend to follow is we use most significant bit on the left and least significant bit on the right. But again, as you have correctly said, there are some textbooks which use the reverse convention. Like if you look into some books on computer architecture, they start the bit numbering from 0 on the left and they go up to 31 on the right, but that is just a convention. Okay. Do not get too much confused with that. Now, as I said, most of the books they follow a convention where the MSB is on the left, the least significant bit is on the right. So, if you want, you can follow this convention, right. Okay. So, I do not have any more pending questions as of now, but let me spend some time talking about a few other things. Well, I talked about the tools which can be used to minimize functions, like the tools from Cadence Synopsys. Now, these tools are very expensive tools. As an individual, you often do not have access to these tools. So, what do? There are some software which are available in the public domain. Public domain means they are available on the internet. If you want, you can download them and use. There are some public domain logic minimization tools that are available. There is a tool, you remember the name of the tool is ABC. It is a very powerful tool. This tool have been developed at the University of Berkeley, and you can download the tool, use it, and it can do very good minimization for you. You need not have to buy a software to carry out minimization. Okay? But again, as I told you that these will be useful when you are doing some real design work. For your courses, to pass your examination, you will still have to do the Carnot map and the tabular methods, because those are the questions which will be asked, right. Okay. So, I have a couple of other questions. One question is interesting. It says, at what stages does error detection and correction occur in a computer or digital system? Well, the answer is very straightforward. You need to carry out error detection and correction whenever there is a chance of an error. Now, the question is, you will have to identify where the chances of errors are maximum. Let me cite a few examples where there are possibilities of errors, and therefore, error detection and correction are important and must be used. Okay? First example, when you store some data on the disk, hard disk, you have seen hard disk, secondary memory, they use some magnetic mechanism to store data. They have a metallic layer on a plastic surface, and very small magnets are created on top of it in tracks. Depending on the polarization of the magnet, which side is north, which side is south, you can say that data is 0 or 1. Now, well, these magnets are very close to each other, and with time, as you use the disk, you must have seen some file might get corrupt, some data errors start happening, which means some data that were stored, they start getting changed, a 0 becomes 1 or a 1 becomes 0. This may happen regularly also. So, whenever you are storing some data in a disk and reading data from the disk, automatically there is an error detection and error correction mechanism which is going on. Whenever during reading the circuit finds that there is an error, so it does not use Hamming code, it uses some more complex kind of a code, it uses something called cyclic redundancy code, CRC. So, whenever there is an error is detected, it detects that there is an error in the disk, sector error or something. Okay. This is one example. Take another example. Well, you know computer network. Computers are connected over wires, over fiber optic links, over satellite channels, data are being communicated, billions and billions of bits are being communicated. Now, during communication, there can be errors. Think of a satellite communication link. Satellites work on microwave. During cloudy weather, signals become very weak. So, some of the zeros again may become 1, ones may become zeros during that period. So, you may need to have error detecting and correcting codes when you are transmitting and receiving data over such links. Think of another situation, satellites, spacecrafts, or even airplanes. Well, as you go higher above the earth's surface, you are exposed to different kind of charged particles, alpha rays, gamma rays and so on. These are charged particles. They bombard your circuits, and if you have a memory, and if these charged particles bombard those memory, they can penetrate the plastic cover, they can go inside, and some of the memory cells which are storing 1 may become 0 or a 0 may become 1 because of that. So, in spacecraft or in aircraft, in this kind of a hazardous situation, let us say hazardous environment, whenever you are using a computer, error correction is mandatory. You must use error detecting and correcting mechanisms, right. So, this is one. And another question is interesting, why the binary of 8 and -8 are same? Well, your question is interesting, but let me also say your question is not correct in a sense. Let us say, means I presume you are talking about 2's complement. Well, in 4-bit number representation, if you recall the lecture, in 4 bits the maximum positive number you can represent is +7, 0, 1, 1, 1, and the largest negative number you can represent is -8, it is 1, 0, 0, 0. For 2's complement number representation, I mentioned that the weights of the bit position are 2 to the power 0, 2 to the power 1, 2 to the power 2 and -2 to the power 3. Okay. In decimal -8, 4, 2, 1. So, technically you can never represent +8 in 4 bits, because in 2's complement the weight of the most significant bit is not +8, it is -8. So, whenever you write a number like 1000, it is actually -8, not +8. So, do not confuse these two. Okay? So, means your question is very interesting. This is a very common place where people get confused. See, when you talk about unsigned numbers, then all weights are positive 1, 2, 4, 8. Then in 4 bits you can represent up to 15. 1, 1, 1, 1 means 15, but as soon as you start talking about signed numbers, your sign bit becomes of a negative weight, it becomes -8. Okay? That is why 1000 is no longer +8, it becomes -8, right. Okay. So, in this course, as you have seen, I have started with the basics of zeros and ones number representations, and then I have been progressing through switching algebra and ways to minimize and realize, represent it using circuits. You see, the main motivation for this course is again designing circuits and systems. If you think about again VLSI design, very large scale integration, designing chips, well, inside the chips ultimately we are implementing gates. Okay? Now, using CMOS, CMOS is a technology which is most commonly used today, complementary metal oxide semiconductor. Now, in CMOS technology, you can implement NAND NOR gates very easily, NAND, NOR and NOT. Building AND and OR gates are relatively difficult. So, whenever normally in a 2-level logic system you are building a circuit using AND and OR gates. So, when you are using CMOS kind of a design, you will be designing circuits using NAND and NOR gates. That is why we often say or ask questions like, you implement this using NAND gates, you implement this using OR gates, using NOR gates. So, you may ask, why suddenly we have to do using NAND and NOR? The reason is, today the technology that we use to build the chips, there everything is NAND and NOR gates, that is why. Okay? Well, some more questions have come. Well, again there is a related question has come, let me start with that. The question is product of sum and sum of products, which is more preferred? Well, again it is preference. If you are using AND or NAND, then sum of products is preferred, but if we use OR AND or NOR gates, then product of sum will be preferred, because you see sum of product means AND followed by OR. Any 2 level AND OR circuit can be replaced by a 2 level NAND circuit, and a product of sum means a 2 level OR AND realization, and 2 level OR AND is equivalent to a 2 level NOR realization. Okay? Just remember this. Well, the second question, well, the question is which applications of circuit use product of sum and which use sum of products. Well, there is no unique answer to this. There are some functions which if you express in sum of products, you may see that you can minimize them very well, and the final circuit requires very small number of gates. But there may be some other functions where you may see that while using SOP, minimization is not very easy, but if you use POS, minimization is much more, number of gates required is more. So, it depends entirely on the function. Generally you cannot say which is good, which is bad. So, you will have to explore with respect to the function, that how many true minterms are there. If the true minterms are larger, there is a chance of them getting formed into larger cubes and more minimization. So, you say if the number of true minterms are less, then possibly product of sum may be better, because number of false minterms will be larger. So, you will be having larger 0 cubes and POS may be more efficient. But again you cannot generalize this, you will have to actually work out and see that which is better. Okay? And there is another question, how primary memory and secondary memory designed in terms of 0 and 1? How primary and secondary memory differs in terms of 0 and 1? Okay, second question is a little confusing. Okay, let me tell. The way primary and secondary memory are implemented, they use entirely different technology. Like I have just now said, hard disk, they are built using magnetic technology. They are not created or manufactured using transistors. There are small micro miniaturized magnets on a surface of a rotating disk that are used to store data. Nowadays you talk about flash drives, the USB pen drives you use. Now in your new laptops you have solid state disks, they call solid state drives. That is a different technology. That is again a transistor based technology, that is not a disk, not a magnetic disk. That is again some kind of semiconductor transistor based technology. Okay? Using those transistor memories you store 0 and 1, and in main memory where you are storing, you can say that I store some kind of flip flop. So, in the classes we will be discussing flip flops. So, using flip flops you can store a 0 and a 1. There are so many different kinds of flip flops, D flip flop, T flip flop, JK, SR. You can store individual bits in flip flops. When you talk about main memory, there are some parts of main memory which are built using this kind of technology, flip flops. But majority of the main memory today that is developed using another kind of a technology that is called dynamic memory. Dynamic memory is interesting. Dynamic memory is again semiconductor memory, but there data are stored as charge on a tiny capacitor. So, you store the charge on a capacitor and leave it. The capacitor will slowly discharge because there are so many leakage paths. So, periodically you will have to refresh. So, you might have heard the term called dynamic memory. Most of the main memory in computer systems today use dynamic memory because they are much smaller and their size is much larger. That is why people use dynamic memory. Okay. And your other question was how primary and secondary memory differs in terms of 0 and 1. Okay. The question is not very clear. For secondary memory, I said magnet direction will indicate 0 or 1, north south or south north. And in flip flop, when you store a data, again the output is 0 or 1, that will indicate that you are storing a 0 or a 1. Okay. So, it depends how you are storing the data. Now, there is a question on Memristor. Well, you see, normally these topics are not covered in a course of this type, but I thought I should also give you a flavor of some of the emerging technologies. Memristor, well, I did not explain in much detail, I mean in the lectures. You see, Memristor essentially is a two terminal device, just like a resistance. A resistance has two terminals, Memristor also has two terminals. Memristor is built using some kind of oxide material, titanium dioxide, there are other oxides also using which you can build memristors. Now, the unique property of memristor is that when you apply a voltage across the memristor, some current will be flowing, some charge will be flowing. Because of the flowing of the charge, the resistance of the device will change, and the material is such that this change in resistance is non-volatile in nature. Non-volatile means even if you switch off the power, this new resistance value will remain. So, you see, now we have a technology using which we can implement memory so easily. This is called resistive memory, memory as resistance. So, if I apply a voltage plus on this side, minus on this side, maybe the resistance will become high. If I apply reverse voltage, resistance will become low. Well, I can call one of them 0, I can call them one of them 1. Now, memristor based memories have till today they have not hit the market, but they will be coming very soon. They are very simple to fabricate. Each memory cell will consist of only a single memristor, okay? And the storage capacity will be extremely high, extremely large. And there was another question regarding imply function using memristor. Well, you see, I mean, you need not have to worry too much about this functionality using memristor. What I want to emphasize is the main application of memristor what people are talking about is, first thing is in memory. I can build very large capacity memory systems using memristor, maybe 1 terabyte, which using any other technology we cannot build today. A chip, a single chip containing 1 terabyte memory, that is what people are talking about. Now, using this imply, or there is another method called magic, memristor aided logic. The idea is, inside the memory you are storing some data 0 and 1 on the memristors. low resistance means 1 and high resistance means 0. Okay. Now, you can say that when you are storing this resistance values, using this imply or magic, you can also carry out some logic operations. So, you have a computing environment where memory and computation can be done in the same place. This is a new kind of an architecture, okay? New kind of an architecture paradigm. This is called in-memory computing. So, you need not have to worry about for the questions or for this course. I just talked about Memristors just to give you a flavor of some emerging technology, right. So, I think we have covered almost all the questions that have been raised, and this was a very enjoyable session. I hope it was also useful for you. If there are any other questions, I think there is one. Yeah. There is one question which is a little confusing. It says, what is real example of AND gate? Well, a real example, are you trying to mean some real life example where this AND function is implemented? Well, you can, I can give an example like this. Suppose there is a missile launching system. Normally, this kind of strategic means warfare devices, they are not under the control of a single individual. Let us say, we say that if these 3 persons are all present together and if they say yes, only then the missile will be launched. So, you can say this is an example of an AND operation, a 3 input AND. The 3 input are these 3 officers. If they say yes, it means the input is 1, 1, 1, 1, then the output will become 1. Okay, this is one example you can talk about. And the other question is, which is more preferred, Milli or Moore machine? You see, this is not a question of preference. What we have said is that sequential machines can be categorized into 2 types, Moore machine and Milli machine. There are 2 different characteristics. In one of them, it says that the outputs depends only on the states. So, if you know the states, from the states you can directly compute the outputs. In the other kind of machine, it says not only the states, you also have to know the present inputs. Based on both of these, you will have to compute the output. Now, I have taken some examples in the lectures, you will see some example of a Moore machine, some example of a Milli machine. I took an example of a traffic light controller, then a sequence detector, then, well, let me take an example of a serial adder. Well, I am adding 2 numbers where bits are coming one by one serially, and as the state I am storing only the carry value. Now, from the carry I cannot generate the sum, that is the output. I need to also know what is my current AI and BI, the 2 inputs coming. So, these 2 inputs plus the state, the carry was 0 or 1, they will decide what will be my next sum output bit be, right. But if you think of a traffic light controller kind of an application, it moves through some state. If the state is this, then I know green light should glow. If the state is this, I know red light should glow. Then the separate input is not important at all. So, Moore or Milli machine, these are 2 different categories of sequential machines. It is not that one is good or one is bad or which one is preferred, nothing like that. Okay. Fine. Well, this is an interesting question. Design of NAND and NOR gate in CMOS, which is preferred and why? Well, you recall how you design a NAND gate in CMOS. You have the PMOS transistors on top, you have the NMOS transistors in bottom. In the top, the PMOS transistors are in parallel, and in the bottom, the pull down, the two NMOS transistors are in series. But in NOR gate, it is the reverse. The two PMOS transistors are in series and NMOS transistors are in parallel. Now, there is one characteristic of PMOS transistor is that they are slower, they have higher resistance as compared to an NMOS transistor of same size. So, you can say that transistors with the same size, a PMOS transistor will be having higher resistance than an equivalent NMOS transistor. So, for a CMOS NOR gate, in the pull up, two of the PMOS transistors were coming in series. So, the series resistance would be larger in that case. So, whenever it drives an output line, in output load I can think of a capacitance. So, every output load we treat as a capacitance load. This output capacitance will be charging or discharging. So, when you are charging through this pull up, these two p type transistors will be coming in series, their resistance will be higher. So, the delay of a NOR gate will be higher in CMOS, but in a NAND gate the two PMOS transistors are coming in parallel. So, the resistance will be at most the resistance of one of them, okay, parallel of the two resistances. So, in CMOS NAND gate is better because NAND gate the delay is less, they are faster. Okay. So, I think we are almost reaching the end of this session. So, I have enjoyed interacting with you. So, what I would strongly recommend, let us keep the forum Ask a Question alive. You ask all your questions on the forum, myself and also the TAs. Well, one of the TA Abhay Kole is here and the other TA Dr. Kamalika Datta, she is sitting at NIT Meghalaya right now in the hill station of Shillong. She is also watching this session. So, means we are all active in the forum and we shall be trying to respond to your questions, answer your questions as promptly as possible. So, let us keep the forum active, because forum is not only for you, for also the others. The others can learn a lot by looking at what the peers are asking and what discussions are going on there. So, it is not only for you to visit the forum whenever you have a question, just see what kind of discussions are going on there. Okay? It will be an enriching experience, this much I can assure you. Okay? So, with this, let me thank all of you for joining this live session, and I hope to conduct such a live session again later in this course. Thank you once more.